Hello students, welcome to this video where we are going to introduce what we call the electronics principles, or rather electrical and electronics principles. So to start, throughout the entire study of electric circuits, we are going to be using what we call Kirchhoff's laws. That's what we're going to be using most of the times whenever we want to describe the analysis of a given circuit. But before discussing this, it is very much essential for us to understand or to familiarize ourselves with the following terms. So we need to know the following terms. The first one has to be what a node is. The second one has to be what a branch is. The third one, you need to know what we call a loop. And lastly, you also be required to understand what a mesh is. Okay, all right, so if I'm to define what a node is, what a branch is, what a loop is, and what a mesh is, I'll define them as follows. Try to do this. Okay, so a node is a junction where two or more elements are connected. So what's the meaning of this? If we say a node is just the point where two, or the junction where two or more elements are connected, this actually simply means, if we talk of an element, we simply mean any resistor which is connected to a certain wire, and if those same wires are meeting at a certain junction, we call that point as a node. I'll give a single example. If this is a point where a resistor and a resistor are being connected, we say this point is called a node. So this has to be the element which is connected along that wire, and this one which is also connected along that given wire. All right, let me try to define what a branch is. So I'll put a definition for branch on this part. I'll say a branch is a section with two or more elements connected between two nodes. By the way, a branch, it can just be something which has an element connected between two nodes. It can either be two elements or a single element. Sometimes you can also say that is a branch. If this is a wire, that is a wire, I'll say this has to be a node, and that is also a node. If you connect a resistor between these two nodes, this node and that node, we say this has to be a branch. So if we try to close this circuit here and the other circuit on that given part, you will understand that a certain part of a closed circuit like this one, this is what we call a loop. So a loop is just a closed part of the circuit. Then if you say mesh simply means the total sum of loops, or a group of loops. We can say that is what we call a mesh. But let's try to understand what Kirchhoff's law is all about in details now. Okay, all right, we proceed. I believe in first year we were told that actually we have two kinds of Kirchhoff's laws. We have two kinds of Kirchhoff's laws. And what are these kinds of Kirchhoff's laws? The first one is said to be Kirchhoff's current law. Some people will call it as KCL. The second one is what we call Kirchhoff's voltage law. Say this is KVL. Wow. So how do you determine the signs based, or how do you describe this? How can you describe what we call Kirchhoff's current law as well as Kirchhoff's voltage law? What description can you give for you to understand these same two laws? Let me try to explain a bit on how we are going to be able to understand and when are we supposed to use these same two kinds of Kirchhoff's laws. Alright, so according to Kirchhoff's current law, that's how we state it. We say the total current, in short, summation of current entering the junction has to be always equal to the total current leaving the junction. Suppose this is your circuit and we understand that always current is moving from the positive terminal going to the negative terminal. So it has to move in this given direction, meaning that the current going in that direction, I1, is entering the junction. These two currents are leaving the junction. So the summation of current entering the junction is always equal to the summation of current leaving the junction. The formula to use, or rather in simple ways for you to state the current, Kirchhoff's current law, you just need to use this to be the simplest way of describing it. That's how we describe what we call Kirchhoff's current law. Let me try to do the second one, which is Kirchhoff's voltage law. Okay, so if you want to state what Kirchhoff's voltage law is, it states that the total voltage in a closed loop has to be always equal to 0. What does it mean? This actually simply means if you pick this to be your first loop, you will understand that here we are going to have a voltage, on this we are going to have a voltage, and on that we are going to have a voltage across it. Same applies if you come to this part, you're going to have the voltage supplied, the voltage on this one, and the voltage on that. Remember, this one belongs to this loop and that loop. So whenever I'm dealing with the second loop, I'll count this. Whenever I'm dealing with the first loop, I'm going to count this one to be part of this. Now, how do you determine what is it that you're supposed to understand when it comes to the determination of signs? How do you determine the signs whenever you're dealing with the battery and whenever you come to the resistor? Remember, if this is a positive terminal, that is a negative terminal. When I come on the part of the resistor, the part you encounter first, it has to be a positive terminal because this is where the current reaches first. So this is going to be positive and this is going to be negative. Same applies even here. This has to be positive. This will be negative. That will be positive. This will be negative if current is pointing in that direction. But if you pick current to be being produced from this part, this is going to be positive part and that is going to be a negative part. That's what you need to understand most of the times. But how do you determine the same signs when you are using Kirchhoff's voltage laws? How do you determine the signs for the resistor as well as the voltage, or rather the battery, or the voltage supplied, the voltage source? How do you determine? Let's try to understand that now. All right, we proceed. So according to the issue of how you can determine the sign, you need to follow two different conditions. The first condition says on a battery, if we go from positive terminal to a negative terminal, there is a voltage drop, meaning that the electromotive force across that same battery has to be negative. Reason being, you are moving from the positive part to the negative part. You are decreasing in the voltage. And if you go from negative terminal to the positive terminal on a battery or any voltage source, the voltage has to be rising, or there is a voltage rise, meaning that I'm moving from negative terminal to the positive terminal. When do you apply this condition? This condition mostly applies whenever you want to use KVL, Kirchhoff's voltage law. If you come to the issue of using Kirchhoff's voltage law, actually, we are going to be applying these same conditions. And that's what I'm going to be demonstrating to you guys as I'm trying to do a team to do some sorts of examples and calculations. This is the first condition. Let me try to give you the second condition so that we should be able to understand what actually is needed for you to fully understand the concept behind this. Okay, and the second condition says when current flows through a resistor, there is a voltage drop across that resistor. Okay, so the condition behind that is if you move or you go through a resistor in the same direction as current, there is a fall in potential, meaning that the voltage across that same resistor has to be negative. What's the meaning of that? If you check properly, we know that if current is moving in that direction, the first terminal of the resistor to be encountered has to be positive terminal, like the way I've indicated it here. The negative terminal is going to be at the end. So as I'm trying to move from this, or I'm moving in that given direction, there is a fall in potential across this one. Reason being, we are moving from a positive terminal to a negative terminal, meaning that voltage is dropping across this same resistor. Same applies to the first condition I gave you. So if you are moving in the same direction, voltage across this has to be negative because we are moving from positive to the negative part. So I'll say here we are going to have a fall in potential, which is going to be negative voltage. Here, I know that current is moving in that given direction, and here we are moving in the same direction as current. You've chosen to move in the same direction as current. That's why this is negative. But since current is moving in that given direction, there is a drop in voltage across this one. But you've decided to move in the negative, in the opposite direction, meaning that you are starting from the negative terminal going to the positive terminal. In short, we are moving in the opposite direction to the direction of current. So across this, we are going to have a rise in potential, meaning that the voltage across this one has to be positive because we are moving in the opposite direction. There is a rise in potential. These are the best conditions that we should always be able to follow as we are trying to handle many examples. As we are trying to handle many examples, let's try to have a simple example that we are going to solve for us to fully understand and what are the steps that we are supposed to take. Okay, so this has to be our first example, and most of the times you will understand that questions that requires you to use Kirchhoff's laws, sometimes you can't be given the direction of currents. So what are the steps that you guys are supposed to take always? In complicated circuits, you understand that sometimes KCL is not even important to use it. We are going to be applying KVL only. Okay, but for this one, this is a usual circuit. Even in the first year, you guys you did something like this, but now it doesn't have directions of currents. What are we going to do for us to fully understand what is happening on this one? So let me try to just list down some steps that we are going to be taking. Step number one, say assign the currents in various branches. Have you seen I've used the word branch? I hope you understand what it means by the word branch. Step number 2, apply KCL at any junction. Step number 3, say apply KVL. Remember, this is Kirchhoff's current law, and this is Kirchhoff's voltage law in the closed loops. Okay, so these are the steps that we are going to be taking for us to solve this question to get the currents in each and every branch. Let's try to understand and follow the same steps until we come up with the final answer. Okay, now you guys, if you check this circuit, we are going to understand that I've signed the so-called currents. The current is moving in that direction towards this junction, or rather towards that node. The other one is pointing towards the direction, I mean in the downward direction. The other one is moving in that given direction, meaning that you've assigned this the currents in the branches. So what you do now, you have to use two different loops. We have loop 1 and loop 2. The loop we're talking about here has to be this one, and the one we're going to be using has to be that one. But the second step is telling me that we have to apply KCL. How do you apply KCL? So according to KCL, say use KCL. So according to KCL, we are saying the summation of currents entering the junction must always be equal to the currents leaving the junction. So how many currents are entering the junction? We just have a single current, which is I1. Then these two are leaving the junction. So say equal to I2 plus I3. In other ways, this can also be written as I1 minus I2 minus I3 equal to 0. And this is going to be your first equation. Equation number 1. Wow. Let's try to go to the second step. What are you supposed to do on the second step? So on the second step, we need to concentrate on the closed loop now using KVL. So whenever we are using KVL, or what we do is this. You have to choose whichever direction you want, either clockwise, or anti-clockwise. Some applies even on this one. So allow me to use clockwise direction. This. So if I'm moving in the clockwise direction based on the arrow, this arrow shows that here we have a negative terminal here, we have a positive terminal. Even there we're going to have positive, negative. Even here we're going to have positive, negative. Somewhere there I'm going to have positive, negative. Then here we're going to have right, let me try to do it like that. I'll say negative, positive, since current is moving in that given direction. Now if you choose to move in the clockwise direction, pay much attention here. We are going to understand that according to the first condition, we are saying if I'm moving from negative to positive, this guy is going to have a positive voltage. But on the resistors, even here we're going to have positive, negative. On the resistors, we are moving from positive to the negative, meaning that the voltage across this has to be negative. The voltage across that is going to be negative as well, because we are moving from negative to the positive. Same applies to this. If you come to this given loop, you choose to move in the clockwise direction. Now let's try to understand it in an easy way. I'll say this is R1, that one is resistor 2, that one is going to be R3, I'll say this has to be R4, and finally this has to be R5. So what are we supposed to do? If we are using this as our first loop, we are going to understand that if I'm coming on this part using the first condition, I'm moving from positive to the negative. I'll say E1. I'll label this one to be E1. I'll label that one to be E2. Wow. Then if I'm coming on this resistor, I'm moving from its positive terminal to the negative terminal. This has to be negative voltage. So I'll say V, I'll label it as V1. Same applies to this. I'm moving from positive to negative. We are going to have negative V2. If I come on this one, I'm going to have negative V4 because this is resistor number 4. Remember KVL, that's what we are using. So I'm saying using KVL in the first loop, in loop 1. So in loop 1, I'm done with loop 1. All the resistors and voltage source, it has to be done in that way. And this is what we are going to have. So how do you come up with the voltage according to Ohm's law? So Ohm's law, it tells us that voltage has to be equal to what? Current multiplied by the resistor. So here we have the current. What current is passing through the resistor 1? What current is passing through the resistor 2? And what current is passing through this? So we are going to put this where there is V1 and its resistor. So here we have current number 1 is the one which is passing through this resistor. So what we are going to do, I'll say we have 2 as E1 minus, what is V1? V1 has to be the multiplication of R1 multiplied by the current which is going through this, which is I1. So we're going to have I1. What is your R1? R1 is 10 minus, there we're going to have I1 multiplied by 10. Here we have I2, so the resistor there has to be 5 equal to 0. Let's try to simplify this. If you try to simplify this, we are going to add this and that. It will give us negative 20, 5i2 equal to negative 2. Remove the negatives multiplying throughout by negative. We're going to have 20i1 plus 5i2 equal to 2, and this has to be equation number 2. Let me try to do likewise to this part. So if I'm coming to this part, allow me to move in the anti-clockwise direction. So say using KVL in loop 2. So using KVL in loop number 2, what are we supposed to understand from this very part? So what we are going to notice here is this. Since I'm moving in this direction, meaning that here I'm going to start from positive coming to the negative. But for this, the current is moving in that given direction. Even here it is pointing in that direction, and as we are moving in the opposite direction. So since we are moving in the opposite direction, we are encountering the positive first, going to the negative first. This simply means we are going to, sorry, let me try to do like this, because I'm following the current which is coming in that direction. So I'm encountering the negative first, going to the positive, meaning that there is a voltage rise on this part based on the second condition. So we are going to have a positive voltage there, we are going to have a positive voltage there, but for this one we are going to have a negative voltage because we are encountering positive. That's when we are coming to the negative part across that same resistor. So here we are going to have E2. For this one we need to have positive voltage. For that one we need to have positive voltage. For this one we need to have negative voltage just hope you guys know that according to this law, it has to be something like this. In a closed loop, we need to have 0, something like that. All right. So what is this? This has to be 4. What is this? We have I3 is the one which is coming towards this, multiplied by that. We are going to have 20 I3. Same applies even on this part. We need to have 20 I3. What is on this part? We need to have 5 equal to that. If we try to do some sorts of multiplications, additions on this part, we are going to start with this. I'll say negative 5I2 plus 40 I3 equal to negative 4, and this has to be the third equation. So you guys pay much attention to this. How do you handle this in a simple way without suffering? Check the first equation. How many variables is it having? It has 3 variables, meaning that this equation and that equation needs to have the same 3 variables, and we are going to have 3 equations. To handle the same 3 equations, just use matrix format. Matrix format by getting the determinant. A calculator which is here is going to solve everything at once and give us the answers. So let me try to arrange these same equations. We have I1 minus I2 minus I3 equal to 0 as the first equation. For this one, there is one variable which is missing, and what is that variable? Which is I3. So we have 20 I1 plus 5 I2. I'll put a 0 on the one which is missing, equate to that, and that has to be the second equation. Here, one thing which is missing is I1. Then we have minus 5 I2 plus 40 I3 equal to negative 4. So when coming up with a matrix, how do you come up with a matrix in this way? How do you come up with a matrix in this way? How do you come up with a matrix in this way? So based on this, my matrix, just from here, my matrix is going to be like this. I'm going to write it like this. Okay, so on the part of equal sign, we have 0, 2, minus 4. Here, I1, I2, I3, and the variables are 1, minus 1, minus 1, 20, 5, 0, 0, minus 5, and 40. Let's try to get back to this once more. Check properly and use 3 by 3 matrix. So the best way to handle this without even your determinant, what, and so on, forth, what, no, I know what I'm doing. Or what you can do is, there is a calculator which is going to punch this at once and give us the answers as I1 equal to I2 equal to I3 equal to. But when punching on the calculator, we don't punch the things that are here. I'm just trying to demonstrate how everything is going to be arranged. So when punching, I'm going to punch the things that you are able to see on this part. Okay, get your calculator. Probably I'm talking about this kind of a calculator. If you get this kind of a calculator, switch it on, go on, what you can do is say you go there, you go on 5 where it is written equation, then go on second position, the one which is having 3 by 3 matrix. So second position, it will give us something like that. Then I'll start entering the numbers. I'll say 1, I enter, -1, I enter, -1, I enter. Then on the part of equal sign, we have a 0. The moment you enter this, it will come to the second row. Okay, so we have 20, we have 5, we have 0, we have 2. Okay, then we have the third row, 0 there, -5 there, then we have 40, and finally we have -4. The calculator itself is designed in such a way that if you say equal to, it will just automatically give you the answers. So it has to give you the answers. If it has been written like that, punch where it is written S equal to D on this part, this button which is here. I'll say equal to the first current, which is I1, is equal to 0.064. Okay, I'll say equal to again. The second one is equal to 0.15. Then the third one is probably a negative answer, -0.082. Meaning that you've gotten your currents. That's how we handle any question which is coming in this same way. All right, based on these to be our answers, let me try to drop one more question for you to practice at your free time. Goodbye. Don't forget to subscribe to our channel. Leave your comment if it is making sense to you. If you've come across it at your first time, just try to subscribe, comment, and share with your friends so that at least everyone can be able to benefit. Try to wait for more questions. We are going to be solving. This was just an introduction to electrical and electronics principles 1. Thank you very much for your time.